Good morning, dear students. Today we are going to discuss about the 12th standard organic hydroxyl compounds and ethers book back questions. So far we have discussed the lesson completely. Today onwards we are going to discuss the book back question one by one. Okay. So hydroxyl compounds and ethers, the short answer type we are going to discuss. One by one we are going to discuss now. Okay. First question. The first question is, identify the product or products are formed when a 1-methoxypropane is heated with the excess of HI and name the mechanism. This is a question you have. What's the question? Identify the product are formed when a 1-methoxypropane is heated with the excess of HI. The excess of HI and name the mechanism. Okay. First of all, you have to write the formula for 1-methoxypropane. Methoxy CH3O, propane CH2, CH2, CH3. This will be the 1-methoxypropane. Okay. When heated with the excess of HI in excess you need to mention, then heated. Heating simple. See, whenever it's treated with HI, the I propose to go with a smaller alkyl group. You know very well, ethers contain two types of alkyl group, one larger, one smaller. See, this is a smaller part, this is a larger part. The I always tend to go with a smaller part. This is a logic. Okay. But when you take the excess of HI, the excess of HI will treated with another product and finally all will become a iodide, alkyl iodides. Okay. So if you simply equivalent amount of HI, if you take the smaller alkyl part will become a alkyl iodide, a remaining part of alcohol. If you take a excess of HI, the excess of HI it completely convert the both alkyl group into iodide and water. See how the reaction takes place. See, as you know very well, whenever treated with HI, I propose to go with a, let me, for the convenient purpose, I am writing the equation downward, okay. You are getting that CH3I as a product plus CH3, CH2, CH2, OH propeller. This is the first product. You are taking excess of HI mean again this is one of the product, no, this product will treated with the excess of remaining excess of HI. Further it will give a CH3, CH2, CH2, I plus water. So this is two products. See what happened? All the alkyl group present in ether converted to iodide, methyl iodide, propyl iodide. Both are become iodide and water. So what are the product they asked? When the excess of HI is taken, you need to give a methyl iodide and propyl iodide as a product. Okay, these are the product. Then one more subdivision question is there. That is a mechanism. What is the mechanism? What are the alkyl group involved here? Primary alkyl groups are involved. So this mechanism will be SN2 mechanism. SN2. Primary alkyl groups only involved in this reaction. So what is the mechanism they asked? The mechanism involved in this process is called SN2 because primary alkyl groups are involved in the reaction. Primary here both methyl group and propyl group are primary alkyl group. If another primary alkyl group involved, the mechanism is obviously it should be a SN2 mechanism. Now it's clear the first question. What is the first question they asked? What when the excess of HI is reacted with the ether, what happened? Whenever the excess of amount of HI is taken, all the alkyl groups converted to iodide and water. This is a program. Okay. Now the stepwise I am going to write. This is you are getting a first alcohol and a methyl iodide smaller group, and further the excess of HI treated with the propyl alcohol, you are getting that propyl iodide. Okay, it's clear. Let us move on to the second question. Okay. Draw the major product formed when a 1-ethoxypropionene is heated with the equivalent, that is 1 mole, equivalent amount of HI. See in the first question, excess of HI. Here, equivalent amount of HI is taken. Okay. Okay, first you need to write the 1-ethoxypropene. CH3, CH2O, ethoxy, prop-1-ene. Prop means 3 carbon is there. The first carbon contains double bond. This is one ethoxy propene. First of all, you should write the formula first. So ethoxy propene. This is in the first carbon, ethoxy group is attached. So one ethoxy propene. Okay, is heated with the HA. This is the HA. What is happened? Equivalent amount of HI. So as you know very well, as I said earlier, the I is proposed to go with the smaller alkyl group. See, alkyl, in ether, if you convert the alkyl group, this is one alkyl group, ethyl, another one alkyl group is a propene group. So, which is a smaller group, you know very well. The smaller group number of carbon is less, that is called smaller alkyl group. CH3, ethyl is a smaller alkyl group. So, here the I goes, you are getting that ethyl iodide, CH3, CH2, I. Ethyl iodide is one of the product plus prop-1-ene all, that is called, the H is goes here, OH, CH, double bond, CH, CH3. Okay. Ethyl iodide 1, 2, 3. Propene, 1 propene, 1 R. Propene, 1 R. 1 propene, 1 R. See, in the question, they asked, draw the major product. You write me, you can write the equations. No worry. They ask you draw the major product, mean they expecting that a bond line structure. If you write it like this, it is also right. For this a bond line structure, if you write a bond line structure for this ethyl 1 carbon, ethyl, okay, CH3, ethyl, CH3, CH2O, then CH 1, 2, 3 carbon. See how bond line structure is there, CH3, CH2O, CH, here double bond, CH, CH3. This is called a 1-ethoxy prop-1-ene. 1-ethoxy prop-1-ene. When it is heated with HI. Heated with HI, what is the product? Ethyl iodide. Ethyl iodide, how I am writing in the look at there? CH3, CH2, here CH3, CH2I. Ethyl iodide. Ethyl iodide. Plus, what is the name? Prop-1-ene, 1-ene, 1R. Prop-1-ene, 1R. So, prop-1-ene, 1R, how will we write? Say, look at this. OH is there, starting with OH, CH, another CH, in between the CH, double bond is there, CH, then CH3. Okay. So, if you want to write a bond line structure, you can write for this question. Say, CH3, CH2, ethyl iodide, same product, and prop-1-ene, 1. This is the first carbon, 1, 2, 3 carbons are there. So, prop in first carbon contains double bond, propene. In the first carbon itself, OH group is present. So, prop-1-ene, 1R. That's right. Okay. This is second question. If you have any doubt, you can ask me what is the problem here. Nothing is there. Draw the major product formed when 1-ethoxy prop-1-ene is heated with the 1 equivalent of HI. Okay. In the first question, excess of HI. If excess of HI is there, again you can add. But here only taken limited amount, 1 equivalent of HI. So there is no further reaction. One alkyl ion and alcohol. You are getting this. If you write this is the equation form, they ask draw the major product. It's not worry. They are expecting that you need to draw the bond line. You can draw the bond line also for this question. Let us move on to the next question. There is a question number 3. Suggest a suitable reagent to prepare a secondary alcohol with an identical group using Grignard reagent. This is very, very important. As you know very well in organic, Grignard reagent is a very, very important reagent. Most probably, many number of organic compound can be prepared from the Grignard reagent. That's you know very well. Okay. What is the question is asked here? Suggest a suitable reagent to prepare a secondary alcohol. You know very well, alcohol can be prepared from the Grignard reagent. Okay. When a Grignard reagent is treated with dash and dash, see here, if you treat a Grignard reagent with a formaldehyde, you don't forget, always you remember this Grignard reagent, Grignard reagent treated with a formaldehyde, you are getting primary alcohol. Okay, you are getting primary alcohol. Whenever acetaldehyde you are treated with a Grignard reagent, you are getting a secondary alcohol. You are getting that a secondary alcohol. Likewise, ketone, if you use the ketone, you are getting that tertiary alcohol. You always remember this. This is a key point you should recall. So whenever formaldehyde is treated with the Grignard reagent, you are getting the primary alcohol. Acetaldehyde, you are getting the secondary alcohol. Acetone or ketone, you are getting the tertiary alcohol. Okay. Now let us move on to the question. What they asked? In a question, they asked a suitable method to prepare a reagent to prepare secondary alcohol. You are there mentioning acetaldehyde. If you take acetaldehyde with the Grignard reagent, you are going to get a alcohol. Let me write this. Acetaldehyde. Acetaldehyde, if you write always like this, it is very useful to write the equations. Okay, acetaldehyde. Then Grignard reagent, methyl magnesium bromide. I am writing this. Yeah. What is going to happen? This bond, if it goes like this, let me write like this: CH3, CH is there, O MgBr. MgBr from Grignard reagent, then CH3 will be coming here. Okay, like this. Then acid hydrolysis, we open up put acid hydrolysis here. What is going to happen? CH3, C, it should be like this. CH3 will be like this. OH plus MgBr. This is the Grignard reagent. Now you are getting the secondary alcohol, propanol. Okay, 1, 2, 3. OH propane is a secondary carbon, so it is secondary alcohol. So now you get that. What is suitable reagent? Acetaldehyde is a suitable reagent. When it is treated with the Grignard reagent, you are getting that is secondary alcohol. Now it's clear. What is the question asked? What is the suitable reagent to prepare secondary alcohol in the identical group using Grignard reagent? That is the best reagent to prepare a secondary alcohol with the Grignard reagent is acetaldehyde. If you take acetaldehyde with the Grignard reagent, you are getting the secondary alcohol. How it is called a secondary alcohol? 1, 2, 3 in the secondary carbon OH group is 2 propanol. 2 propanol is a secondary alcohol we have prepared. Now it is clear. If they ask the question primary alcohol, you take a formaldehyde. If they ask a tertiary alcohol, you take a acetone. Okay. Let us move on to the next question. So let us see the fourth question. What is the fourth question? What is the major product obtained when 2 moles of ethyl magnesium bromide is treated with a methyl benzoate followed by the acid hydrolysis? See, ethyl magnesium bromide is a Grignard reagent. It is a methyl benzoate is a ester. What they are indirectly saying? How treatment with a Grignard reagent with a ester like. Okay, methyl benzoate means benzoic acid and methyl group should be there. So methyl benzoate. This should be a methyl benzoate. When treated with the 2 moles, this should be recalled. How many moles they have taken? 2 moles. 2 moles of CH3 or C2H5 you can write. CH3 CH2 MgBr. Okay, this is the reactant they have given. The 2 moles, first 1 by 1 mole. 1 mole what happened? Another 1 mole, next reaction. Okay, always let me, for the convenient purpose, I am going to write these 2. C2H5, C double bond O, CH3 plus C2H5 MgBr. What is going to happen? So whenever Grignard reagent, the MgBr will be coming, the alkyl will go there, so you can have a reaction like this. C6H5 C O MgBr, and already OCH3 is there, OCH3 the ethyl group of this will go to here. And acid hydrolysis, if you do acid hydrolysis, what is going to happen? C6H5, C6H5, C2H5. Okay, double bond. Here, this group will be go out. OMG. So, as a result, whenever ester is treated with the Grignard reagent, you are getting a ketone. Or you are getting that a ketone when a 1 moles. Further, you know very well when a ketone, the second step, the ketone C6H5, C, C2H5 double bond O. This is the ketone. Is treated with the, because 2 moles we get taken, 1 mole only here utilized here. The another mole of ethyl magnesium bromide is taken. Just before I have said that when a formaldehyde is treated with the Grignard reagent, you are getting primary alcohol. When acetaldehyde is taken and you are treated with the Grignard reagent, you are getting the secondary alcohol, as well as whenever ketone, if you take treated with the Grignard reagent, you are getting a tertiary alcohol. That's we are going to have now. What is going to happen? C6H5, C, C2H5 is there, O, MgBr, and what is the ethyl group will be there? That ethyl group. Now if you do acid hydrolysis, H plus H2O converted to tertiary alcohol, C6H5, C2H5, C2H5, OH. You are getting the tertiary alcohol. C, the ketone treated with the Grignard reagent, you are getting the tertiary alcohol. Tertiary alcohol, you are having this. So that's all about the question. The question is asked that when 2 moles of ethyl magnesium bromide is treated with the methyl benzoate followed by the acid hydrolysis. Okay, what is the major product? Major product. When 2 moles, 1 mole if you take, the ketone will be there, the major product will be like this. This is a tertiary alcohol because alcohol group you are getting the 2 different alcohol. This is a tertiary alcohol. If they ask name, how we can name? See, long chain you have to see here C2, 3, 4, 5. This will be a long chain of the okay. So third carbon you are getting the phenyl group. And OH is there, totally 5 carbon. Okay, 1, 2, 3, 4, 5. Pentanol. Okay, pentanol. 3 phenyl, pentane, 3 or 3 pentanol. 3 phenyl, 3 pentanol, the name. 5 carbon, 1, 2, 3, 4, 5. 5 carbons are there. So, OH is there, pentanol. The OH group at present the third carbon. So, 3 pentanol and the third carbon contains phenyl group is there. 3 phenyl, pentane, 3 ol. Okay, this is the product. Now it's clear what is the major product is this. Now let us go to the next question. What is the question? Predict the major product. When a methyl butene is converted to alcohol in each of the following. So alkene is converted to alcohol in 2 different methods. Acid catalyst hydration, hydroboration, hydroxylation using Bayer reagent. This is the question they asked. So what is the methyl butene, how it can convert to alcohol by following 3 ways. One by one we are going to see. So acid hydrolysis. First of all, you have to write the formula for methyl butene. Okay, what is the methyl butene? So CH3, CH3. Okay, this is a butene, 2 butene, 2 methyl, 2 butene. This will be right. In the question, 2 methyl butene should be 2 methyl, 2 butene. It is an unsymmetrical alkene. It is a unsymmetrical alkene. 2 methyl, 2 butene. It is an unsymmetrical alkene. What is called unsymmetrical alkene? In both side of the either side of the double bond, the same group is there. That is called symmetrical alkene. But two different groups are there. That is called unsymmetrical alkene. See here, there is unsymmetrical alkene. So it's not balanced. This is called the 2-methyl-butene. Now, acid catalyst hydrolysis. Acid catalyst hydrolysis is nothing but a H plus H2O. Acid catalyst hydrolysis. It is undergoing Markovnikov rule. What is called Markovnikov rule? When unsymmetrical alkene is undergoing acid hydrolysis, the negative part of the addendum should go to the carbon which has the least number of hydrogen. That is called Markovnikov rule. In the water, negative part of the addendum OH minus. Now, simply you are getting that is CH3, CH3. The OH should come to this carbon OH, then CH2, CH3. This is the product you are having. Acid hydrolysis of unsymmetrical alkene, you are getting that. What is the name? Totally 4 carbons are there. Butane. Second carbon, methyl group is there. So, 2-methyl-butane-2-al. Okay, 2-methyl-butane-2-al. When a 2-methyl-butene is acid catalyst hydration bond, we are getting that a 2-methyl-but2-al. Okay, this is undergoing Markovnikov addition. Then, hydroboration. Then 2-methyl-butene. If you write 2-methyl-2-butene, 6 times of CH3, double bond, CH3. 1 to 2-methyl-2-butene. This is treated with the B2H6. Okay, B2H6 hydroboration is going to happen. Then 2 times of CH3, CH3. Here the H is going here. CH. CH3. For convenient purpose, I am writing this CH3 above and then okay, now it is balanced or non-balanced. There should be 2 borons should be there, 2 borons there. The entire system 6 times. Already the entire system is 3, 1, 6 H's. Already 1 H is added here. That will be 6. It is a balanced product. Okay, this is adduct part. Further, what happened here? It is treated with a peroxide. 3 moles of peroxide. In the presence of basic medium, OH minus. In the presence of basic medium, you are getting that peroxide in the presence of anti-Markovnikov product. This is a Markovnikov product. This is anti-Markovnikov product. As a result, you are getting that CH3, CH3, H, CH, CH3, OH, anti-Markovnikov. You are getting anti-Markovnikov product. Okay. So what is the anti-Markovnikov product? Here, there is most number of hydrogen. In these 2 carbon, where OH should be added. Here, OH is the carbon which are having least number of hydrogen. This is a product. Here, what is happening? The carbon which are having the more number of, only 2 carbons are there. Among the 2, it has a more hydrogen, so OH should go there. This is a product. Plus POH twice. This is hydroboration. Okay. So you want the name of the product. You can give a name. 1, 2, 3, 4. 1, 2, 3, 4 carbons. In second carbon contains OH group. So what is the name? Butane 2-al, because second carbon OH is there. Then what about the third carbon contain methyl group? So 3-methyl-butane 2-al. The name is 3-methyl-butane 2-al. Then let us move on to the hydroxylation using Bayes reagent. Hydroxylation using Bayes reagent. What is called Bayes reagent? That you know very well. called alkaline KMnO4. What is the role of the base reagent? Whenever base reagent used in the alkene, they are producing diols. They are monols. They are given diols. So write the reactant, that is 2-methyl 2-butene. 2-methyl 2-butene. This is a reactant. When it is treated with the base reagent. Base reagent is nothing but a cold alkaline KMnO4. Water and if we take this, it will give a diols. CH3, C, CH3, CH, CH3, OH, OH. Diol. 2 OH groups are there. Diol will be the product. Hydroxylation, OH. Hydroxy group is added. That is called a hydroxylation. When you are doing the hydroxylation, you are getting the diol is a product. Okay. So this is how, what is the question? Predict the major product when a 2-methyl butene is converted to alcohol. All the cases, 2-methyl 2-butene is converted to alcohol in a 3 different way. By using acid catalyst hydration, you are getting this product, Margonica product. When a hydroboration, you are getting the anti-Margonica product. When a hydroxylation, by using base reagent, you are getting diols. This is how alkene, unsymmetrical alkene is converted to alcohol in this 3 way. Okay. Let us move on to the next question. Let us move on to the question number 6. Question number 6 is nothing but arranging the following in increasing order of their boiling point. Okay. Arranging the following in the increasing order of the boiling point. If you see a theoretical question, you just write the formula. Then you can get easily the answer. Okay. What is the given? Butane 1-2-all. Butane 1-all. That is 2-methyl propane 2-all. So butane 2-all. CH3, CH, OH, CH2, CH3. That is a butane 2-all. Then butane 1-all. CH3, CH2, 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 OH. Okay. Then 2-methyl propane 2-all mean CH3, CH3, 2-methyl propane 2-all. Okay, this is the formula. Now it is clear when I asked to write the formula. Okay, this will be a secondary alcohol. This will be a primary alcohol. This is a tertiary alcohol. Okay, it's simple. So they are ordering the asking to arrange the increasing order of their boiling point. What is the in isomeric alcohol? These are the isomeric alcohol because same number of carbon, everything is same, but alcohol different alcohol, primary, secondary, tertiary. In isomeric alcohol, the boiling point will be tertiary will be very low, then secondary will be greater than the tertiary. Primary alcohol will have a topest boiling point. Now if you arrange it, what is the answer? This will be the first. So increasing order they are asking among this lowest tertiary. So 2-methyl propane 2-all. That is the lowest. And secondary alcohol you have to write butane 2-all topest. Primary alcohol, so that is butanol. So this is the increasing order of their boiling point. In isomeric alcohol, tertiary will be lowest boiling point, primary will be the highest. So arrange this. Then let us the second segment of this same question. They have given the same way if you write the formula, it will be very easy. First thing propanol. Okay, propane 2-all. So they are given propane 2-all mean the formula will be like this. Then propane 1,3 triol. Okay. CH2 2, 3, 4. Okay. then 1,3, yeah, 1,3 2, 3, 4. Now, this is easy, only isomeric alcohol. This is not isomeric alcohol, this is different alcohol. That is, these two are monohydric. This is monohydric alcohol. Monohydric, only one OH. This is trihydric, 3 OH. This is dihydric, 2 OH group. Okay. Now, you know very well they are asking boiling point, increasing order that boiling point. Boiling point increases with number of OH group increases. It is obviously this, it contains three OH groups are there, so it will be top first boiling point. Then this number 1, number 2. Among the isomeric, primary will have more, so this is number 3. This will be number 4. Okay. Now what is the increasing order they have asked? So lowest propane 2R. Propane 2R is the very lowest boiling point. Above this primary alcohol, that is propane 1R, and then dihydric alcohol, propane 2,3 diol. Okay. Then you are having the trihydric alcohol, propane 1,3 triol. So the reason they asked, number of OH increases, boiling point increases. So trihydric alcohol have most boiling point. Then next place you are giving dihydric alcohol. These two monohydric. Among these monohydric, second will be lowest primary. The second will be lowest, then primary monohydric, and then dihydric, trihydric. This is the explanation which you need to give. The question is asked, arrange the boiling point in the increasing order. All are alcohol. In the first segment, everything is isomeric alcohol. So primary, secondary, tertiary. Then primary alcohol will be more boiling point. So you are arranging like this. Here in this case, in second segment, you are having that a different type of alcohol. There is monohydric, dihydric, trihydric. Among the monohydric, there are two, secondary and primary. So secondary will be most. So secondary will be very least boiling point. Primary, dihydric alcohol and trihydric alcohol. This is increasing order of the boiling point. So far we have discussed 6 questions today. Let us see the next further question in tomorrow. Thank you.